friends, welcome to the Boolean Brain. In continuation to the LeetCode Daily Challenge series, where we are breaking down the daily LeetCode challenge problem statement and live coding it with you. We are on day 16. Let us take a look at today's problem statement. The title says maximum square area by removing fences from a field. There is a large m minus 1 by n minus 1 rectangular field with corners at 1, 1 and mn containing some horizontal and vertical fences given in arrays. H fences and V fences respectively. Horizontal fences are from coordinates H fences of I to 1 to H fences I to n, and vertical fences are from coordinates 1 to V fences of I to m from V fences of I. We have to return the maximum area of square field that can be formed by removing some fences, possibly none, or minus 1 if it is impossible to make a square field. We want to make a square field. Since the answer may be large, return it modulo 10 power 9 plus 7. Okay, so friends, if you are carefully following the daily LeetCode challenge series, yesterday's problem statement was similar to the today's problem statement. Even in previous problem statement, we have to maximize area of a square hole in a grid, but the condition was each initial starting size of each squares is 1 by 1. So there were all horizontal and vertical lines present, and we have been given some H bars and V bars where we had to basically remove one of these and get a sum of get a maximum square possible, and we have to return that. But in today's problem statement, if you carefully observe, it is mentioned that we have the initial state is not from 1 to 1. For example, this case, each cell is of size 1, 1. But if you observe the example 2, you can see that the size is 6 by 7 and the horizontal fences are 2. So the initial starting horizontal fence is only 2, and similarly vertical fence is only 1, which is at fourth column. So, and with this as a starting point, we now have to find the maximum square that can be possible. So, the yesterday's logic of finding the square uh, is not going to work here, because yesterday we just simply went ahead with the greedy approach. We initially sorted all the H bars and V bars, and we tried to find the maximum count of continuous elements in it, because each cell contain of size 1. So we when we had just maximum size of horizontal and vertical, we just multiplied them and return the answer. Okay, but in today's case, the initial starting point doesn't contain sizes of 1 by 1 cells. So we have to solve this. Now, how what is the difference in the previous and today's problem statement? The problem statement is basically the starting point. So if this is the starting point, let's consider this example too. If this is the possible initial starting uh, uh, square, so how can I find all possible lengths in horizontal direction? First, let's try to find the length in horizontal direction. In horizontal direction, you can see since 4 is one fence, what are the possible 1 to 4? 1 2 4, isn't it? Apart from that, 4 to 7, 4 to 7, and 1 to 7, 1 to 7. So these are all the possible width in horizontal way. Why is this? Because we have one fence at the center. We can have combinations around this only, because the problem mentions of removing the vertical or horizontal bars, right? So if I remove this, my entire becomes 1 to 7. But if I keep this as it is, then possible widths become 1 to 4 and 4 to 7. So these are all my combinations. Similarly, if we think of vertical direction, we have one in vertical direction. If you see, we have this at the second position. So what is the difference that I can have? I can have either this 1 to 2, 1 to 2, or I can have 2 to 6, 2 to 6. Apart from that, if I remove this horizontal second line, can I get this vertical entire length of 1 to 6? Yes, I can. So now once I have all this data with me, can I simply find out if there is any overlapping? Because I want to find the square only. And in order to find the square, I need to have the same sides in horizontal as well as vertical. If there is some length which is overlapping, that is my answer, isn't it? So if you see here, 1 to 4 size is 3. Similarly, 4 to 7 size is 3. 1 to 7 size is 6. Here size is 1. Here size is 4. And here size is 5. So if we carefully observe, there is no common element. 3 and 6 are present in horizontal, and in vertical we have 1, 4, 5. So there is no common. So if there is no common, we simply return -1, isn't it? So that's the approach. First, find all the elements of possible widths in both horizontal and vertical, and then simply go on iterating and find the common element if between them. If let's say 3 was common, I would have simply written 3 into 3. So that's the side into side. Okay. Now let us try to write the solution for this. Now I I want this difference, right? And I don't need to keep the starting and ending point. I am only concerned about this vertical and horizontal edges. So what I will do, let me um yeah, declare something for the edges, horizontal edges. Okay. Similarly, we can have for vertical edges. In horizontal edges, we need to pass edge fences. And in vertical, we want to pass the vertical. We also want, let us complete this function. Now this is going to return us some set or a data structures with the store variables, right? So let's take it as a set. So let's use unordered set because time complexity of unordered set is in the average it's of 1, the insertion and the accessing. So okay, good. Now once I have all the edges from horizontal as well as vertical, so what I can do now, I want to find, I basically want to iterate on one of the edges, okay, for in I equals to 0, I less than price, I plus. I want to check if if my vertical edges contains, I'm iterating on edges and I want to check if, sorry, if V edges contains, if V edges contains of I, it means that that is my possible answer. So I'll declare a possible answer here, which is going to also my return variable. I simply try to update this answer equals to maximum of answer comma the current element, isn't it? Okay, great. Now when this function is complete, let us try to find the all possible cases like this. So 1 to 4, 4 to 7. How can we do it for a given fences? I can simply start iterating on On this, I'll start another loop. J equals to I plus 1, j less than I plus plus. Now, this is I and J combination, right? So I have this, I have this. I want to find basically the combinations. So my initial starting point is basically 1. So I also need to add, I need to consider by adding 1. So what I will do before starting iterating on array, I will fences, let me take it with this fences dot push back the starting point 1. Okay. And we also need to push the ending point. So I let us pass m as well here. I also pass the n and let us check in n and pass it here. So I added the starting and ending point because my fences uh, only contains the internal boundaries, not the external ones. So I pass it here. I passed it here. Now, before working here, I need to basically sort this out first because they need to be in order to find the ij. So fences dot begin fences dot end. Okay. Now I will check. I since I'm returning a set, I need to declare a set here. Why I'm using set? Because there might be possibility of difference between, in this case, 1 to 4 is 3, 4 to 7 are also 3. So I don't want to compute it twice. I only want one copy. So I am using set. Set contains insert function. Says of j minus fences of I. Okay, looks good. And at the end, I'm simply returning the set. So we added the first and last fence. We sorted them out. We declared a set. We started iterating on fences.size and j starting from I plus 1 because I want to compute for all ij combinations. And I simply inserted my difference into this set. Here I'm getting the set and uh, I'm declaring the answer, iterating on one of the fetch. Since I'm iterating on edges only because I need common maximum common from these 2 points. So I am declaring answer initially assigned to 0, and if the VHS contains HHS of I, it means there's a possibility to update the answer, and that's how we will compute it. Let us try to run this. Okay, if VHS contains does not the subscript operator. Okay, let instead of doing this, let us add to H in HHS. Okay, let us try to run now. Okay. Okay. I don't need to return just the common answer. In the problem statement, it's mentioned that we have to return modulo 10 power 9 plus 7. So what I will do, I will first compute the So since this might become uh, a bit large, so long it into answer modulo 10 power 9 plus 7. Okay, let us try to run this. Invalid operands 10 power 9. Okay, let's get rid of this for now and try to run this if it's accepted. 10 power 9. What? Yeah, it's passing, but one more is failing. Oh, okay, okay. So another one base condition, if in the answer I do not find any common, right? If answer exactly equals to 0, I simply need to return minus 1. Okay, let's try to run this. So these are some, corner critical cases which we have to be a little extra careful whenever we are writing the code. Cannot be segmented into int. Okay, we are returning the int to segmented into int. I think we need to convert it into long. Yeah, and yes, the problem statement is successfully accepted. Let us quickly describe the time complexity and the space complexity. So if you carefully observe, we are initially calculating all the edges, and these edges is running over the length of loop, initially sorting it out, running over the length, and having two internal loops to find all the possible pairs. So that basically gives us O of h square. If h is, the horizontal, if h square, and we in terms of space, we are using a set to store the different possible combination sets, and again that might go to O of h square plus O of v square. V square because we are working on it, iterating on vertical as well as the horizontal. So both time and space complexity goes to O of h square plus v square. I hope the problem statement, the approach with how we approach to the solution and the live coding is very clear to you. If you have any doubts or queries, please do let me know in the comments. And if you really like the video, please consider giving a like. And if you're new, please subscribe to the channel. Thank you so much.